So we're talking about parallax, and that's the shift in the sky that a star would do because of the motion of the Earth. The distance is related to the parallax. The distance is 1 divided by the parallax. If and only if the angle, the parallax angle, is measured in arc seconds. If it's not measured in arc seconds, it's not going to give you the right answer, because the answer comes out in a unit we call parsecs. So what is a parsec? Parsec is defined to be the distance at which the parallax is 1 arcsecond. Actually, most books, define it in this weird sort of way, and that is that a parsec is the distance at which 1 AU subtends 1 second of arc. Well, what does that mean? It means that if that 1 AU is 1 arc second. It's one arc second from that distance. Well, what's an AU? An AU, or an astronomical unit, is the average distance Earth is from the sun. And so the problem is measuring distances in space is hard. So it was a very long time before they were able to measure the actual distance from the Earth to the sun. Okay. So in order to actually get this angle here, in order to measure that distance, you need to know what this distance right there is in order to calculate it. I mean, if you got this angle and that distance down here at the bottom, so this is a triangle. So if you know this angle and that side, you can calculate that side because that's a right angle right there. But you have to know that distance. And it's very difficult to figure that distance down there. Because how do you measure the distance from the Earth to the Sun? It's not very easy. So the fellow Johannes Kepler figured out the relative spacing of the planets. He said, okay, Earth is 1 AU from the Sun, Jupiter is about 5.2, Mars is about 1.4, Venus is about 0.7. So he figured out all the relative spacing. Saturn 9.5 AU, but we didn't know what an AU was. It was many, many years later. So, but they did know that if you are a distance of, and again, the equation was that distance is 1 over parallax, works the same other way around. Parallax is 1 over distance. So if you are a distance of 1 arcsecond, 1 divided by 1 is 1, so we call that a parallax second, or a parsec. So a parsec is the distance here, so that the angle is 1 arcsecond. Now, if the angle is 2 parsecs, 1 over 2 is 1/2. Okay, so that means that you're going to be so in other words, if your distance is 2 parsecs, the angle is 1/2. So the smaller the angle, so this is 1/2. 1 over 1/2 is 2. If the angle here is 1/5. Okay, so 0.2. 1 divided by 0.2 is 5. And so that would be 5 parsecs. A parsec is the distance that light is the distance that makes 1 arcsecond. So turns out to be, we've later figured out how big an AU is. So we know that a parsec is 3.26 light years. So that means 1 parsec is about 31 trillion kilometers. That's about 19 trillion miles. The closest star is about 1.3 parsecs away. That's about 4.2 light years. Voyager 1 is the fastest thing leaving the solar system. It's not headed towards Alpha Centauri, the closest star, but if it were, it would take about 75,000 years to get there, the fastest thing leaving the solar system. So this gives you an idea as to how big space is. Measuring parallax is difficult to do from the ground because the atmosphere distorts light. It makes it difficult to make the measurements. So a number of years ago in the 1990s, the European Space Agency launched the High Precision Parallax Collecting Satellite, or Hipparcos satellite. When you look at stellarium, one of the things it sometimes gives you is the Hipparcos catalog number of stars. And so that's coming from this satellite right here. Currently, the ESA has a satellite that's been up there for a number of years. The Gaia spacecraft, the Gaia mission, is measuring the parallax of stars to within 7 micro arc seconds. In fact, they're actually saying they might do better than that even. They might get down to a couple of micro arc seconds. That would mean that we're able to precisely measure distances out to hundreds of thousands of light years, practically the entire galaxy we can measure distances to now. In the old days, we could only measure distances to within, a few fractions of an arc second, so we could measure distances out only a few parsecs. So dozens of light years, and then we got to where we could measure up to 100 light years. For a long time, the limit was about 1/100th of just under 1/100th of an arc second, and so that means we could measure out only about 500 or 600 light years. The Hipparchus mission greatly extended that, allowed us to measure even farther, and now we're about to come up with data that's going to be even better. So this column right here gives us distance. So what's the closest star on this list? Closest star, remember, the distance is 1 divided by that. So the smaller that is, the farther away it is, the bigger it is, the closer. So the biggest parallax is going to be the closest star. So what's the closest star on the list? Well, that looks like the biggest number right here. So the star Procyon is the biggest one on that list. So that is a parallax of 0.285. What's the farthest star on the list? The farthest star on the list would be the smallest number. So the smallest number is right here, 0.0032. And that is the star SAO 258660. Okay. So what if I wanted to find how far away were those stars? So, Procyon, we said, had a parallax of 0.285. So the distance is 1 divided by 0.285. Okay, so how do you do that? Well, there's a button on the calculator that does that. Okay, in fact, I mean, you can do 1 divided by, but most calculators have a button that you just enter the thing and it puts it, makes it like that, and there's fewer things. So that's about 3.5 parsecs. Okay, now a parsec is 3.26 light years. So if I want to find out how many light years away Procyon is, that's going to be 3.51 parsecs times 3.26 light years per parsec. Okay, so that's going to come out to be about 11.4 light years. Okay. What was the farthest star on the list? So the farthest star on the list was SAO 258660 and had a parallax of 0.0032. So how far away is that star? 1 divided by parallax, 1 divided by 0.0032. Okay, so 0.0032, 1 over that, and that's going to be about 312 parsecs. So how far away is that in light years? So 312 parsecs times 3.26 light years per parsec. So times 3.26, and so that's going to be about 1,020 light years.